Alright, hello everyone, so welcome again. So in this video I'm going to solve three important problems. So I'm starting with an easy example, then I will do two special examples where we have odd trigonometric functions, okay? Alright, so let's review how to solve this type of a problem. Okay, so the first step is, well, we have odd powers here. Well, in fact, we have two odd powers, 7 and 5. So which odd power to split? Split the least odd power. Now here's a challenge. Try to split the highest odd power. Okay, try to split sine to the power 7 here and try to do the problem. Experience that pain. Okay, you can solve the problems, but it will be painful. Okay, just for one time in your life, try to experience that pain, because if you do that at home, you will not do that in exam. Okay, all right, but still you can solve the problem. Okay, don't get me wrong. Alright, so let's split the least odd power, because I don't like pain in mathematics. So this is what we have. So we split cosine to the power 5. Now remember, we always split a one function out. Okay, now we make a u substitution. What is your u? The function that you didn't split. I mean the opposite function to the what you split. So we split cosine, so it's going to be sine. So then don't forget du over dx. So derivative of sine is cosine. So dx is going to be du over cosine x. Alright, so let's do the substitution. So u is sine, so this is u to the 7 and cosine to the 4x. Okay, I am substituting it to here. Okay, not to here. Do not even touch this now. Okay, forget that you have it here. Alright, so cosine 4, cosine x, and I want to see that cancellation by myself. Okay, so I write this step. So you see, I cancel out cosine. Okay, so what we have here, u to the 7 cosine to the 4 du. Now I shouldn't have x here, right? X as a variable. I need to convert that to u, and then we use Pythagorean identity, my friends. Always use Pythagorean identity. Okay, all right, so here we know by Pythagorean identity cosine square x is 1 minus sine square x. Now we have cosine to the power 4. How can we create that? Well, we can square this, right? So that means cosine to the 4 is 1 minus sine square x to the square, right? Because we had to square the left hand side, so we square the right hand side. So we know sine square is 1 minus u square. So it's 1 minus u square to the square. So we have u to the 7, 1 minus u square to the square. Okay. Alright, so let's see what's gonna happen. Now how do we solve this integral? Well, FOIL it. So if you FOIL it, I'm gonna do this quickly. You will get 1 minus 2u square plus u to the 4. Okay, please do, if you are not comfortable with that, please take time and do it by yourself. Okay, all right, so let's FOIL this furthermore. Distribute that u to the 7, so this is u to the 7 minus 2u to the 9. 7 and 2 will create 9 plus u to the 7 plus 4, 11. Let's integrate with respect to u now. Okay, so if you integrate u to the 7, it's u to the 8 over 8 minus 2u to the 10 over 10 plus u to the 12 over 12 plus c. Well, we can furthermore write u is sine, right? I substitute sine. Sine, oops, I'm sorry, sine to the 8x over 8. Well, this is 2 over 10 is 1 over 5. Sine to the 10x over 5 plus sine to the 12x over 12. Easy, right? If you follow the procedure, if you understand everything, it's going to be easy. Okay, all right, so let's do another problem, a tricky one here. Well, it's not tricky, but there will be hesitant. You will be hesitant to solve this. Okay, sine to the power 5. Now, all right, here you don't have couple of functions, but it's okay. Let's follow the rules. What do? We split the least odd power. Well, we have only one function, so sine to the 4x times sine x. We split out of one sine. Now what is u? U is going to be, you split sine, so u is cosine. Now you will be like here, well, hang on a second, we don't have cosine in the given problem. So are we allowed to choose u as cosine? Absolutely yes. Okay, even though cosine is not there, stick into the rule that u is going to be the function that you opposite function that you split. Okay, so Even though that opposite function is not in the integral, it's okay. We are still going to choose u as cosine x. Let's differentiate. Du over dx is negative sine x. So that means dx is du over negative sine x. So let's do the substitution. Alright, so sine 4 and sine x and dx is du over negative sine x. So if you did it right, you will cancel out that, and then we are left with sine to the 4 and du. I know we don't have u here except here because of course we didn't have cosine in the function, but it's okay. Now we want to write sine to the 4 in terms of u. We use Pythagorean identity. Sine square x is 1 minus cosine square x. Sine to the 4, you square this, so you square the right hand side too. So u is cosine square, so 1 minus u square square, right? So this will be 1 minus u square square du. So we will FOIL it here. So it will be 1 minus 2u square plus u to the 4. Okay. So FOIL it means 1 minus u square to the square is same as 1 minus u square times 1 minus u square. So multiply that out. Let's integrate. So if you integrate 1, you get u minus 2u to the 3 over 3 plus u to the 5 over 5 plus c. What is u? Cosine, right? Cosine, right? Yes. Okay. Just to make sure. 2 cosine cube x over 3. See, it's easy. Alright. Now, this is the answer. Okay, so let's move on to the final problem. So the final problem is going to be sine x cosine square x. Alright. Okay, you will be hesitant here too. So what is the odd power? Do we have an odd power? Of course, we have sine x. It's sine to the power 1. So it's still odd, okay? Alright, so let's split the odd power. Oops. We can't split it furthermore, right? Because it's already 1. How can you split 1? Well, it's okay. It's already done for you, right? Sine to the power 1 means 1 is the best case. When you have power 1, that's the best because it's already done for you. Okay? So what is your u is going to be? Think about that. U is, yes, you guessed right, it's cosine, because even though we explicitly didn't split here, sine x to the power 1, we treat it like we have split it. Okay, so u is going to be cosine. Okay, all right, we assume that sine x is like it's split already. So du over dx, because when you take du over dx, it's negative sine x, it will cancel out this sine x, right? So dx is du over negative sine x. All right, so let's substitute both of these things. Sine x, well, cosine square is u square because u is cosine. Dx is du over negative sine x. Oh my god, this is going to be the easiest problem. Sine x cancel out and you get minus u square. Isn't this easy to integrate? If you integrate u square, it's u cube over 3 plus c. What is u? Cosine. Okay, so cosine cube x over 3 plus c. Here we go. This is the solution. Alright, so if you follow the procedure, it's very easy. Okay, so what is the procedure? Split the least odd power. That's the first step. Okay, and then remember, when you split, just take out a one function. Okay, and then make a u substitution. Your u is the function, that opposite function for what you split. Okay, so if you split cosine, your u is sine. If you split sine, your u is cosine. So it's either sine or cosine every time. Okay, all right. Now then make a u substitution, and don't forget, you have to replace u, and don't forget to replace dx by du. Do that carefully. Okay, all right. So if you do it correctly, it will help you to cancel out the term that you split, that single term. And then if you have any excess terms, remove that excess terms, remove that excess x terms, convert them into u by using Pythagorean identity. Okay, and then after that you will have an integral just in terms of u. Well, from there you have to use basic integration rules and algebraic tricks and everything. All right, So that's it for trigonometric integral problems involving sine and cosine. In the next video, I'm gonna explain how to solve trigonometric integral problems when you have tangent and secant. Okay, all right, and I want you to master this topic very well, because you're gonna use it in trigonometric substitution, your favorite integration technique, right? I know, yeah, trust me. Okay, solving these type of problems is might be the last step in your trigonometric substitution problems in that future topic, so you really wanna master this topic. Okay, all right, so I will see you in that future video. Thank you very much for watching this video. Bye bye.